In this lecture, we're going to continue our coverage of survival analysis, and we're going to examine how this is carried out by using an example of a research study. And in this particular example, in this hypothetical study, this study aimed to examine maintenance therapy, therapeutic interventions for children that are in remission from acute lymphoblastic leukemia. So these are children who've already been treated for ALL, and the study aims to examine if the maintenance therapies are sufficient to keep the children in remission. And so, by that definition, the key event in this particular study is the reoccurrence or the time of cancer remission in weeks. And so, if there's a sign of that cancer has reemerged, then that is the key event in terms of the time from entry into the study to the time of remission. And the event is going to be examined as a function of the predictor variable. And so in this hypothetical study, the children were randomly assigned to this new drug, this new maintenance therapy. So either they received the key medicinal ingredient in the drug, or they received the placebo or the control drug. And the drug in this case is just simply abbreviated as 6MP, whereas the children randomly assigned to the control group received a similar looking therapy, but it did not have the key medicinal ingredient. And so this research design is one that involves random assignment and is intended to examine differences between the treatment group and the placebo group, and with the goal of 21 patients entered into each of the two groups. And so these are the raw data during the course of the study here, where the placebo group have these following measures. And so each of these measures indicate the time. Okay, we go back up to our event here, the time in which this first child was in cancer remission, and this first child was 1 week. The next patient was 1 week. The next patient was 2 weeks, 2 weeks, 3 weeks, so on and so forth. In terms of the data collected for the treatment group, here we see longer periods of time. And just by examining these data, just taking a quick visual, we see that the patients randomly assigned to the treatment group had overall longer periods of time. We see the shortest time was 6 weeks as opposed to 1 week in the placebo group, into suggesting to us that this new drug, this new maintenance therapy, seemed to be effective in keeping the patients into remission. The asterisks here, we see one for 6, one for 9, 10, 11, 17, 19, 20, and a few others here at the bottom. These indicate that these participants, so these all represent individual patients, are right-censored. And so these all represent patients that remained in remission after the conclusion of the study. So you can see here on the low end, this particular patient that was in remission for 6 weeks, but is right-censored, this would represent a patient that was entered into the study quite late in the study window. So for the duration of that study, this was a patient that was entered in 6 weeks before the end of the data collection period, and this particular patient remained in remission after the closure of that study. In terms of relapse, some of the descriptive data here in this hypothetical study indicated that all 21 patients, and you can see that here, in the placebo group, all relapsed with this particular type of leukemia. Within the treatment group, 9 of the 21 patients were found to relapse. So the first point in conducting a survival analysis is to first outline the descriptive data of the number of cases in each of the two groups, if that only has two groups, that hit the key event in that particular study. Now, just a note here that 12 of the patients in the treatment group remained in remission at the study end. And so for those patients that had the data which were right censored, the exact time of relapse, if the relapse happened, was not known. And this was a point made a little bit earlier here for the fourth patient that that had 6 weeks of the key event, but the study period ended for this late admitted patient into the study. So with those data established, the first step is to determine what's called the survival function. And the survival function is summarized as uppercase S as a function of t, or the survival as a function of time t. And so what the survival function attempts to do here is to examine the probability of, in this example, of patients remaining in remission during each of the first 10 weeks of the study. Now, the probability of being event-free at time t, or the survival time, is greater than time t. This is what we're trying to examine in a survival analysis: is what's the probability of being event-free at a particular time, or a time greater than that time t. And so the first step we take here is we're going to start with the placebo patients, and recall that we had a sample size of 21. And so in this particular group here, all the participants that were entered into the study were found to relapse. Because the key event in this analysis occurred for all 21 patients, there was no right censored data. And so the number of follow-ups in a survival analysis, provided that the event occurs, will decrease each week. And that's because the participants experience the event or the relapse. Remembering the remission is the key event that is measured. So if we start with the placebo group, and we start with the calculation of the survival function, in the first week, and we'll see a table of that on the next in the next video. But in week 1, 2 patients were found to have relapse, and so our number of those patients that remained in remission is 19. So remember, we started with 21, 2 had relapsed, and so the number that are still in that remission period is 19. And so the first step is to calculate the conditional probability of remission in week 1 in the event that a patient is in the placebo group and doesn't receive this maintenance therapy. And this is calculated in specific to week 1 as the number of patients that are still in that remission period, or the number of cases that have not reached the key event in question, divided by the total sample size. So the denominator here is the total sample size, the total n in the placebo group, which is 21. We drop 2, so it's 19 divided by 21, giving us a conditional probability of 0.91, or 91%. And moving on to week 2, we find in the placebo group 2 more patients had relapsed, that had experienced the event. So what this does is now we have a new sample size. The new sample size is the total number in week 2 that are still in remission. The total sample size after week 1 was 19, but during week 2, 2 more had relapsed. So our new sample for those that remain in remission is 17. So to calculate the conditional probability of remission in week 2, we follow the same formula. It's just that the numbers change. So we have a new sample size because we lost these are two that had experienced the event, and we bring that denominator down to 19. But in week 2, 2 more had relapsed, so that further decreases the number down to 17, giving us a conditional probability in week 2 of 0.90. So the first step in calculating the survival function is to first calculate this conditional probability. Once the conditional probabilities are calculated, and this is conducted on a week-by-week basis, the survival function can then be calculated as a product of the conditional probabilities week to week. And so in doing this, the survival function will continually decrease as a measure of the probability of those remaining in remission in a given week, or stated more generally, as a probability of those cases in the study that had not experienced the key event. So going back to one of our earlier videos, the key event could be committing another crime, if incarceration was the question, the time to, or the point at which a person retires from their job, or a point that a person finds a job. Those are all potential research applications of survival analysis. And so eventually we'll work towards calculating a survival function. So the survival function, we start in week 2. We have our first week. We see our first week conditional probability. On the previous slide, we calculated the week 2 conditional probability, and we just calculate the product of the two, and our survival function is now 0.81 in week 2, because when we take a look at it in week 2, we have to consider the events that occurred during week 1. As we move on to week 3, now you see 3 entries here. So we have the week 1, the first fraction, week 2 in the second fraction, and what we see here in week number 3, we have one more loss in the number in remission, and carrying out the multiplication of these fractions, we end up with a 0.76 or 76% remaining in remission as a function of the survival. And note the pattern here in multiplying through, that the numerator in week 1 becomes the denominator, and that pattern continues en route to calculating our survival function in a week-to-week manner. And so once these data are assembled in a table, they can then be put into a graph called a Kaplan-Meier curve that we'll address in the next video. So this ends our third video here on survival analysis.